draw this diagram. Like in any of the numerical, if they give A is equal to something, so it is understood that they are mentioning about the radius or saying something about the diameter of the core. And your N1 should be greater than N2, or you can say N2 less than N1. Did you finish drawing?
Yes, ma'am.
Yes, ma'am.
Okay. So if I tell you define what is core, so core is the thin glass center of the fiber where light travels. Okay, so if somebody tells you to define what is core, so it is a thin glass at the center of where the light travels. Cladding, it is the outer optical material which is surrounding the core. And what is buffer coating? So all three will be together always. Remember, you cannot separate all these three because fiber, core, cladding, we will see what is the function of the cladding, why we require the cladding. Okay, so these three things always goes together, core, cladding, buffer. Okay, so this forms one fiber unit. Okay, so the buffer coating is the plastic coating that protects the fiber. So here comes one of the functions of the buffer coating. Okay, so it offers protection to the fiber because both core and cladding are mostly made up of glass, and we know that glass breaks. Okay, so to protect it, we require the buffer coating. So the core and the lower refractive index cladding are typically made up of high quality silica glass. Okay, so glass, the composition is basically SiO2. Okay, though they can be made of plastic as well. So fiber, glass fiber, or we have plastic fibers. Okay, now both the fibers are there. We don't have any third material for making the fiber. So glass is nothing but silica, or you can write the chemical formula. It is SiO2. Okay, so this is if somebody tells you to define what is core, if somebody tells you what is cladding, and what is a buffer. Okay, so what is the function of the core? Is the light propagates along the core of the fiber. Students, please write down the keywords. Now, core material is made up of highly pure silica, that is SiO2, and it has to be surrounded by a glass cladding. So nothing more about the core. Okay, it has to be made up of a pure material, that is silica. Okay, the light is propagating through the core and the core is surrounded by a glass cladding. Now you might feel, okay, why not immediately the buffer can be there after the core? Okay, because buffer also protects the fiber, and since light is not propagated through the cladding, then why I require the cladding? Okay, we could have after core immediately the buffer. Now, so what is the role of the cladding is, your cladding reduces the scattering loss. Now, what is scattering loss? We will study in the next chapter. Okay, it is basically some impurities because it is made up of pure silica, but still during the fabrication process, some impurities might be present in the fiber core. So when light rays strike that particular impurity, what happens? The light scatters in a different direction. Okay, so that causes losses. So that is the scattering loss. So if your cladding is there, it reduces the scattering loss that results from the dielectric discontinuities at the core surface. Plus, it adds obviously a mechanical strength to the fiber. So this is the second function of the cladding. It protects the core from absorbing surface contaminants with which it could come in contact with. Like if you are laying down the fiber somewhere, okay, so immediately it's not the core. Okay, the contaminants has to first face the cladding and then the core. So you can say it protects the core from absorbing this contaminants. So are these three things clear? What is the function of the cladding? All of you?
Yes, ma'am.
Only one girl is saying yes. What about the others? Boys, you are sleeping?
Yes, ma'am.
Yes, ma'am.
Nilay? Yes, Nilay?
Yes, ma'am.
Sumit? Sumit, Mitesh, these are some of the names I know because I have taught
Present,
the
ma'am.
naughty ones.
Samjha, ma'am.
Yes,
Samjha.
Samjha. Okay,
Yes.
Sunny हो या सो गए? Sunny. See, this is how the fiber, I had shown you initially a very simple diagram. So the first unit of fiber where I had shown you the core, cladding and the jacket. Okay. So this is this one unit. Yahan pe. Okay. So a bunch of such unit is present over here. Okay. So it can be 4, 8, 12, 16. Okay. ऐसे bunch बनाते हैं यहाँ पे. And see, this is the buffer coating. ये जो एक fiber का buffer coating है, that this is over here. So I have the core, cladding and the buffer coating. Right now in this diagram, you can see some silver or only white color. No, this fibers are, if suppose there are even 12 fibers present over here. Okay, it will be made up of 12 different colors. अभी तो कॉलेज में नहीं जा रहे, otherwise I have the fiber cable in my lab. I have kept it. Okay, so every fiber is, that buffer coating is made up of different colors. Can you tell me why? Because see, when I'm telling about the colors specifically, यहाँ तो white ही दिख रहा है, means there should be some reason. Can anybody
identify?
Yes. हाँ. Two.
Different color means different
Identify.
data.
Different color means
Different type of data.
no, no, no.
मैम जॉब में हेल्प होता है मे बी वो स्लाइसिंग वो स्लाइसिंग
हाँ, ये किसने बोला? ये किसने बोला? मुझे एक्चुअली पार्टिसिपेंट्स लिस्ट नहीं दिख रहे. आई एम शेयरिंग.
मिनीता
Okay, Minita. Okay, very good. Yes. Finally, we have to join a fiber because when I manufacture a fiber, it is manufactured of the length of 2 kilometers or 4 kilometers. Okay. Then some fiber cuts are there. Okay. So that further reduces, and you know the fibers are laid in the entire city. So 2 kilometer, 4 kilometer तो कोई बात ही नहीं है. 75, 100 kilometers तक जाता है. So obviously I have to join a fiber. Okay, now when I am joining a fiber, if there is a cut in a particular fiber, I'll come to know. So if this is suppose of an orange color, I will join it with an orange color only. I will not join it with a white color because every fiber is carrying data of some particular channel. Okay, so to identify which fiber is cut and I'm joining an appropriate, because one fiber of orange color will be over here, one similar unit, this entire unit will be present over here. So I will join orange with an orange, white with a white, green with a green. So this fiber jackets are all made up of different colors. That is the sum, just to recognize which is a particular fiber. Okay, so it does not represent that white will carry more data, green is carrying voice data, blue is carrying, okay, telephone data, nothing like that. Okay, just when I'm joining the fiber, I should join the right fiber. Okay, so this entire single unit of fiber again is put in a fiber jacket. So this again is a second series of jacket. This was the first one over here. There is a second one over here. So it forms a unit fiber structure. Now this unit fiber structure, as I have said, 4, 8, 12, 16 ऐसे bunches के होते हैं. Okay, now see, we have to offer a series of protection. Here you can see this is the entire series of protection. Then this unit fiber structure is again surrounded by strengthening wires. Okay, so these are the strengthening wires. You can see some are big, some are small. Okay, so it is basically to prevent the fiber from any damage, because if I'm laying on the road, some heavy vehicles goes, okay, the fiber might break. So we have the strengthening wire. Then again, I have a copper sheet. Then I have insulation jacket. And then we have the armored protection, very big. Okay, so it is very difficult to cut this portion and all. Okay, and in this armored protection also, we have all this strengthening wires. Plus something is missing over here. When I cut a fiber, the very first thing that comes from here is some thread-like material, which is missing in this particular diagram. Okay, so please listen to this carefully. Some thread-like material is coming over here. So वो जो सुतली बोलते हैं ना, सुतली निकलता है, or in some carpets you see from the sides all those threads are hanging. So similar thing, this entire fiber is covered with those kinds of, you might feel it is like a thread. Okay, now that is called as Kevlar sheet. Write down that name, Kevlar, Kevlar, Kevlar sheet. Now why that Kevlar sheet is there? You might feel अरे इतना सब करने की क्या जरूरत है? We could have made a steel cable or box and we could have kept the fiber inside that steel or iron container, because the weight will increase. That's why we are not going. Okay, so we could have these all materials which are used are very light in weight. Now this strengthening wires, this is so big, it is shown, it is not so big. It is in the form of those, I have said, is those thread likes. It is called as Kevlar sheet. Now if I compare the weight of that Kevlar sheet, it is much less in weight than those steel or aluminium sheet, but it offers more protection compared to a fiber. So the moment you cut the fiber, you can see all those thread-like things coming out. So that is the Kevlar material, which is specifically used, okay, to protect the fiber. So you can see more diagrams in the internet. Okay, so they will show you more series of protection. Okay, plus many other things are there. Now you tell me, these are so many layers of protection which are offered to a fiber. Still, why do you see the fibers? When we lay down the fibers, we dig sufficient distance. You can see on the roadside borders, they dig it sufficiently deep, around 6 meters. They dig it and then they place this entire structure. Can you tell why we dig that much? Do you think the series of protection is still less? Like if a truck goes over here, this will break. So that's why, since there are chances that the fiber cable will be broken, that's why we dig that much and we place the fiber. Do you think that will be the reason?
I'm lightning.
General reason, but a common thing that you might have seen, that we dig on the roadsides, usually on the side, center of the road mein to nahi karte because the traffic will be disrupted, and then we place whatever is this entire cable structure. Any reason can you tell?
I'm lightning.
Lightning, no, we have seen advantages. It is susceptible to lightning. नीचे इतना dig करने की क्या जरूरत है? Around 6 meter dig करते हैं.
Can UV light penetrate inside?
No, it is free from all this.
Protect from water.
Protect from water, no.
Wavelength.
नीचे खोदेंगे तो नीचे तो पानी ज्यादा रहने का chances ज्यादा है.
Shield from vibration.
Vibration, no. Anybody?
Ma'am, there will be no unwanted move inside the if we
There would be unwanted. Be loud.
there will be no unwanted move. Like no one will like touch that fiber cables if it's
That is-
bigger than 6 meters down.
No. That is what he was saying. No vibration. So unwanted movement. So that causes finally vibration. No, that is not the reason.
And to keep it, yeah,
हाँ. बोलो.
ma'am, to keep the
हाँ.
What
Yes,
about
बोलो, मुझे नहीं सुनाई दे रहा है. नेटवर्क का कुछ प्रॉब्लम है. अथर्व was saying something.
yeah, ma'am. Actually, to keep the wire in a specific direction, like the light is traveling. So if it's bend or move some sort of different direction, then it may not transfer the data properly.
No.
हम optical cut down नहीं होना चाहिए इसलिए.
नहीं.
ट्रैफिक नहीं होना चाहिए.
Ma'am, because different areas have different elevations.
No.
Maybe traffic because of the
No.
signal.
No.
Maybe there are a lot of signals around, right?
नहीं. See, if I tell you the reason actually why you are not able to answer is you always think in terms of protection. Yeah, ये कोई ऊपर रहेगा तो गाड़ी जाएगी, vibration होगा. Outside there might be water layers. No, it cannot enter the water. These series of protection will not allow the water to even see. Finally my thing is over here. बहुत छोटा है. इतने सारे protection में there is no chance that water will enter. Plus it will not bend. Vibration won't affect it because ये सारे shock proofs है. Okay, see the reason is very simple. यहाँ पे तुमने fiber देखा है? कैसा है? Okay, do you think all of you, if you have chalk at your home, okay, consider chalk as the core or cladding. Okay, now if you want to protect it, suppose you hold a chalk if you have at your home, और उसको protect करने के लिए immediately you apply the buffer jacket यहाँ पे. If you apply tightly that buffer jacket, क्या होगा? वो टूट जाएगा because it is very brittle, no glass. Okay, so I cannot apply a tight buffer jacket around the fiber. You might feel ठीक है, ऐसा एक बड़ा सा jacket ले लेते हैं और fiber अंदर रहेगा. No, see there are 4, 8, 12 such kind of fibers. So if there is a bigger area and you have these thin fibers over here, वो इधर उधर हिलेगा. Okay, so what I have is tight buffer अगर jacket है, so the fiber might break. If it is a loose buffer jacket, what will happen is fiber इधर जाएगा, उधर जाएगा, ऐसा हिलता रहेगा ना पूरे area में because it is having more space. So when I'm connecting two fibers, it becomes again a problem because it is constantly moving inside this buffer jacket. So what is the way in which I'm connecting a buffer jacket is, we will study it later with the diagrams. Right now I'm just telling you, is we have something called as loose filled buffer jacket. Okay, so loose hai means it is not tight, immediately it is not touching the fiber, and we are filling this vacant area inside the buffer by a petroleum jelly kind of material. So that's why it is loose filled buffer jacket. Like how you have outside a candle stand and then you have the candle and then the wick is there. Okay, why that candle you can consider that wax as that loose filled material, and that thread, wick, you can consider it as the core and the cladding. So we have the concept of loose filled buffer jacket. Okay, so we fill it with a petroleum jelly kind of thing, and this petroleum jelly is liked by the taste is liked by the rats or rodents. Okay, now the fiber, it is laid along the street or somewhere. So this rats and rodents, they have very sharp teeth. Even though we have this armored protection and all, they can very easily cut and they can try to eat this fiber jelly. Now at a distance of 6 feet under the ground, these rats or rodents, they cannot penetrate that much. Okay, so to protect it, you can read it from the internet in detail, even though it is a funny reason, but this is the reason why exactly we dig 6 meter deep and we lay down the fiber cable. Okay, so it is to protect the fiber from the rats or rodents. And why to protect the fiber? Because we are using loose filled buffer jacket. So we are filling it with a petroleum kind of thing. So we will study this in detail again when we are studying the fiber protection. Is this clear? Huh?
Hello, ma'am. But doesn't always increase the cost of the fiber cable?
It increases, but we have to offer the series of protection because finally this is glass. So its tensile strength might be good, but then with a little pressure, it might break. So I have to offer a series of protection. So even though if I say that the fiber is cheap, but the series of protection I have to offer. So initial cost of laying the fiber is costly, but you can see it does not have a lifetime. मतलब lifespan नहीं है ये communication system का. So when I install it, only I have to maintain the thing. So it is like a lifelong thing. So obviously that investment, and in this one strand of fiber, thousands of channels I can send. So I can serve so many customers. Okay, so obviously in long run, I can make up with the expenditure that I am making. But these are the protection that we have to lay. And this is orange color. You might have seen this is orange color or black color. So we have to offer this series of protection. Otherwise, it will break.
Okay.
Okay. So continuing with the next topic, we will be seeing, yes, this is important, the generations of fiber optics. So as I had said, we have 5 generations of the light wave system. Now, I would expect you to write first, second, third generation till 5th, and the words which are highlighted by this brown color, please write down those words so you will understand how the progress goes on. Okay, so the first generation, so we know the range of fiber optics is 800 nanometer to 1600 nanometer. So when the first generation of fiber optics came, it was operating at 800 nanometer. It was all the components were working at 800 nanometer wavelength, and we had only gallium arsenide semiconductor laser. Means the laser that was fabricated at that time, it was only made up of 2 components, gallium arsenide. So we had gallium arsenide laser during the year 1980. So in 1980, the first generation of fiber optics came. Okay, and the bit rate was 45 Mbps. So please write down 800 nanometer. We had GaAs laser. Okay, and the bit rate was around 45 Mbps. Then the repeater spacing was around 10 kilometers. Now, even though the repeater spacing was 10 kilometers, it was considered larger compared to the coaxial cable. So this was the status at the time of first generation. In second generation, we started operating in the second optical window, that is 1300 nanometer. So here the fiber loss was substantially reduced. Again, I'm telling, as we are increasing the wavelength, the losses decreases. So from 800, when we shifted to 1300 nanometer, that is my second optical window, the losses reduced to 1 dB per kilometer, and the fiber exhibits minimum dispersion. Dispersion is again a second type of loss. Okay, one type of loss is where the amplitude decreases. Okay, the signal strength decreases. So this is what we are talking about. Fiber loss, 1 dB, we are talking usually about the signal strength. That is the attenuation loss. Now, another kind of loss, and that is actually a challenge still, is the dispersion loss. What happens in dispersion? Again, this is a separate chapter, but I'm telling you, see, we are transmitting the digital signals. So my information is in the form of 1010. So due to dispersion loss, what happens? The pulse scatters out. Disperse ho gaya, to scatter out ho gaya. Now when it scatters out, the amplitude decreases, but the average power remains the same. So if I measure the power without dispersion and with dispersion, what happens? You will feel our power level is same. Means there is no loss of signal, but no. The pulse has scattered, means the width of the pulse increases. Now, when this width of the pulse increases, there are chances of that the adjacent pulses, they overlap each other. So, Namita ma'am might have taught you ISI, that is intersymbol interference. So, that problem of intersymbol interference comes over here in the case of dispersion. Now, what happens if the pulse is totally dispersed? Okay, you might not be able to recognize whether it is 1 or whether it is, suppose there is 101 signal. ये 11 वाले इतना disperse हो गए, बीच में merge हो गए, so that you don't recognize that there is a 0 in between. You might feel that the signal is 111. So that is your dispersion. So don't worry, we will see all this in detail right now. My pulse width increases, so that is my dispersion loss. So here we had another type of laser which was using quaternary, that is 4 components. Please mute yourself, somebody. So it is made up of indium, gallium, arsenide, phosphide laser, and the bit rate, it increased. Please note down the ones which are written in brown color. So bit rate of 100 Mbps to 1.7 gigabits per second. Okay, so this was available in the early 80s. Okay, and the repeater spacing, here you can see it was 10 kilometers. The repeater spacing increased to 50 kilometers, and here SMF means single mode fiber. So this was the progress from first generation. In the first window, second generation, second window, we had different types of laser. The repeater spacing increased and the bit rate, it also increased. So this was the, I hope you have written all this. Shall I move to the next slide?
Yes, ma'am.
Yes, ma'am.
Okay, so in the third generation, we directly started operating at the third window, that is your 1550 nanometer. Okay, but the dispersion problem was still there at that time. Okay, so during the third generation, we had dispersion shifted fibers. So with the development of this particular fiber, that is your dispersion shifted fiber, we could overcome the dispersion problem. So in the third generation, working at 1550 nanometer, we could have minimum dispersion, and the operating capacity was around 10 Gbps, and the repeater spacing, again, it increased to 100 kilometers. So with each generation, the repeater spacing increased. Okay, so for you, you write down 1550 third generation, the bit rate, repeater spacing, and the dispersion was minimum. Okay, so these 4 keywords. Now tell me, are you very happy with the progress in the generation? हाँ, repeater spacing बढ़ रहा है. See, we are not discussing about any other components. Source है, detector है, wavelength of operation increases, bit rate improvement is going on, losses are reducing, and the repeater spacing is increasing. Do you think some more components are required? Yes, I'm asking you, do you think some more components are required?
High bit rate.
हाँ, वो तो बढ़ रहा है ना, थर्ड जनरेशन, फोर्थ, नाउ वी हैव स्टिल मोर, फोर्थ, फिफ्थ, तो और भी बढ़ेगा शायद. But do you think something else is still required? See, even though I'm very happy that the repeater spacing is increasing, means after every 100 kilometers, now I require a repeater. So do you think repeaters are costly or they are not costly?
They're costly.
Costly. So even though I say that, okay, after 100 kilometers, I will be placing a receiver, a repeater, still it is a very costly thing. Okay, so can I replace this repeater by something else? Now, why do we usually go for a repeater?
Amplify the signal.
To generate signal.
To generate the signal, to amplify the signal. हाँ, तो ये amplifier फिर क्यों नहीं use किया? Repeater ही क्यों use किया? Repeater also does amplification. It reshapes or reconstructs the signal. Many things it does. Okay, so instead of having only a repeater, if there is loss in the signal strength, I could have used an amplifier in between. Okay, it's not necessary that I would have to use always a repeater, because the repeaters are more costly compared to an amplifier. So then in the progress in the fourth generation, okay, what we did is we used the concept. We didn't immediately have a amplifier over here. Okay, in the fourth generation, what we had is WDM technology. Okay, so we were operating in the third window only. Here you can see the operating wavelength. Now, instead of saying 1550 nanometer, you can see it was centered at 1550 nanometer, but we were operating in this particular wavelength, and the concept of WDM, that is wavelength division multiplexing. You might have heard time division multiplexing, frequency division multiplexing, okay, CDMA, and so many things. In fiber optics, the multiplexing technique is your wavelength division multiplexing. As you know, in fiber, we are not using the term frequency. We talk in terms of wavelength. Okay, so multiple wavelengths, we multiplex it together and then we send it through the fiber. So here WDM was used. So we had the concept of wavelength division multiplexing, means your mux demux was produced in the 4th generation. So 4th generation, we had fiber optics multiplexer, demultiplexer. We used WDM technology. It made use of optical amplifiers because we wanted to increase the repeater spacing. So here no name specifically of optical amplifier is mentioned, but optical amplifier was there. Here the name is mentioned. We used EDFA. Please write down capital EDFA. So that is the kind of fiber amplifier. So it is erbium doped fiber amplifier. We will also study what is this particular amplifier in the components. So 4th generation used EDFA amplifier. The bit rate increased to 10 terabits. The repeater spacing, since I am using an amplifier in between, the repeater space was greater than 10,000 kilometers. So since we could multiplex several channels together, so the capacity also of the system increased. So a major progress happened in the 4th generation. 5th generation, what we had is, even though we had this EDFA amplifier, we had another kind of amplifier which was invented by Raman. So we used Raman amplification technique. Again, we will study Raman amplifier when we will have study the chapter of amplifiers, optical amplifiers. So Raman amplification technique was used, so it solved the loss problem, but it made the dispersion problem worse. Now see, the loss in terms of signal strength, we could solve using Raman technique, but again the dispersion problem was there. So again, research goes on to reduce the dispersion. So fiber loss till now in the 5th generation, it remains at 0.2 dB per kilometer. Dispersion problems still are there, even though we have improved dispersion loss, but still research is going on to have fiber of different kind, okay, and many such techniques to reduce the dispersion. Bit rate, you can see it has increased. Repeater spacing 24,000 to 35,000 kilometer. Operating wavelength centered at 1550 nanometer. So this is the things in the 5th generation. So we are currently at the 5th generation of fiber optics. Any question you want to ask in this? Let me see what is the next slide. Yes, any question?
No.
Yeah, okay. So this was the introduction of fiber optics, history, advantages, disadvantages. Next lecture, we will start with the theory. Okay, so optical fiber was a transmission media. Now, what are the alternatives to optical communication?
Wire communication, normal wire.
Normal wire. Any name that you say?
Coaxial maybe.
Coaxial. Okay. Chetan, apart from coaxial cable, any other name? Alternative media for communication?
Twisted pair.
Twisted pair. Okay. Larry?
Yes, ma'am.
Pair, coaxial cable हो गया. Any other alternative transmission media? Ashley?
Wireless communication.
Wireless, name it.
Anything like Wi-Fi or satellite communication.
Wi-Fi or satellite. Okay, so I pick up satellite communication. Fauzan? Any other?
TDM and FDM.
What is the transmission media that you are using in TDM? That is a multiplication technique.
Yeah.
I'm calling about the media, transmission media. जैसे satellite हो गया, satellite through I'm communicating through wires, coaxial or twisted pair, through optical fiber. Anybody? Yes, Saurabh. Saurabh?
Ma'am, microwave.
Yes, microwave. Okay.
Infrared.
Huh? Infrared. Okay. So we are using infrared for communication. Widely used. Okay. So let us see 4 of them. So what are the alternatives to optical communication? See, these are something which are widely used. Saurabh, apna video band karo. So we have first one which initially came was twisted pair, and that twisted pair, it is, you please write down the key points. No need to draw nothing. So twisted pair, we use twisted pair for point-to-point communication. It was used where? In the telephone lines. Okay, so this is the area where the twisted pair was used. Okay, it had a lower data rate. There was high electromagnetic interference. And as we increased the frequency, it was lossy at radio frequency. So this was the first transmission media. We still use twisted pair cables. Then came the era of coaxial cable. Again, coaxial cable was used for point-to-point communication. It was used in a LAN setup. Okay, so wherever we have a local area network, we use coaxial cable. Compared to twisted pair, the data rate improved. So data rate in terms of few Mbps. Okay, the electromagnetic interference was reduced in case of coaxial cable compared to twisted pair cable. The losses were moderate. Okay, so quite an improvement. So coaxial cable was preferred, but still there was some disadvantage with coaxial cable. The repeater spacing, still this problem, even though we say low EMI, the problem of EMI was still there. Then moderate loss. The next one is the microwave communication. Again, it is used for point-to-point link. So we could increase the distance in case of microwave communication. So it's long distance, the bandwidth was large, but the disadvantage of microwave was line of sight communication. Like if I have a microwave tower over here, the next tower should be in the line of sight. Otherwise, communication was not possible. So please remember, for microwave, this is one of the biggest disadvantage, that it is a line of sight communication. Okay, but it is still widely used, and it had high free space loss because the communication was not bounded in any cable or any media. We used free space for propagating the microwave signal. So it had high free space loss. So that was your microwave link problem. Then the fourth one is your satellite communication. Now here you can see, earlier 3, it was all point-to-point communication. In satellite communication, we have point to multi-point. Okay, bandwidth was very large in terms of gigahertz. Data monitoring was possible. But the problem over here was large delay. Large delay, why? Because we have the Earth station. We have to send the signal to the satellite. So there was something, uplink was involved. And then when we are receiving the signal, a downlink kind of thing is there. So I relay the signal and then I get back the signal. So there was a bit delay involved. Even though they are saying large delay, it is not so large. It is in terms of seconds only. Okay, but delay in signal was there. Mobile environment, okay, because the satellite is moving in the space. So it was a mobile environment. So many challenges are there. And this is the biggest disadvantage of satellite communication is it has a moderate life. Like when I launch a satellite in space, the satellite life is there for 7 to 8 years max. Okay, after that, the functioning stops, it goes into an empty space and the communication is lost. So satellites are so costly, but it has a moderate life. Even though we say fiber optics is costly, but the life is there. We don't say कि हाँ ये fiber system is there only for 15 years. No, we might replace the component. Here there is no chance of replacement, nothing. So that is the biggest disadvantage of satellite communication. So the first two media, coaxial cable, twisted pair, had limited bandwidth. Microwave link, satellite link has almost comparable bandwidth. As in principle, the operation mode of operation is same, but the spatial reach of satellite is larger compared to microwave. Microwave had line of sight. With 3 satellites, we can cover the entire globe. Okay, so before fiber optics came in the end, all in the end. So the only long distance communication was satellite, but with fiber optics, we cannot say fiber optics will replace satellite. Both will remain. Okay, so I stop over here. Aparna ma'am has already joined and I took 4 minutes more. So anybody, any question, you can ask me in the next class. I'm not taking a quiz today, so please revise it. Any doubt you still have?